In a complex system with many microservices, the service registry acts as a central directory, like a phone book for services. Each service register itself with the registry, providing details like name, network location, available features. When one service needs to communicate with another, it simply consults the registry to locate the desired service. Let's decode the sidecar pattern in less than 60 seconds. In the world of microservices, managing additional features like logging, monitoring, or security can be complex. The sidecar pattern is like having a trusty companion. It's an auxiliary container running alongside the main microservice that provides additional features. This modular approach enhances scalability, maintainability, and flexibility as each sidecar can be independently updated and maintained. Welcome. Let's navigate through the strangler fig pattern. Imagine your legacy system as a sturdy tree, but over time it became tangled and difficult to maintain. The strangler fig pattern is like a new vine growing around old tree, gradually taking over its functions. This approach allows for the gradual replacement of legacy system with modern solution that will reduce risk and ensure continuity. So that's the strangler fig pattern. Subscribe for more tech insight. We will discuss the API gateway pattern. Imagine your app as a city with multiple entry points. The API gateway acts as the main gatekeeper, the controlling access to your services. Instead of each client directly accessing different services, they go through the API gateway, which routes request to the appropriate service. This also centralizes authentication, routing, load balancing, and simplifying client interaction and shielding services from direct exposure. Let's discuss the backend for front-end pattern. In modern app development, different front-end clients like web and mobile often have unique requirements for data fetching and processing. So this pattern addresses this by creating separate backend services known as backends for frontends tailored to a specific need of each client. This approach improves performance, scalability, and flexibility as each front-end client can have its own optimized backend. So that is the backend for front-end pattern. Hit subscribe for more quick. Welcome to microservice design pattern. Today we will explore the bulkhead design pattern. In software architecture, the bulkhead pattern is like the compartment in a ship, which prevent the entire ship from sinking if one compartment is breached. Similarly, in a system, different components or services are isolated into separate compartments or bulkheads. This isolation helps contain failures, ensuring that if one part of the system encounters issue, it does not bring down the entire system. Welcome back. Today we will explore circuit breaker pattern. In distributed system, service can fail. So the circuit breaker pattern is a fault tolerant mechanism that prevents cascading failures. When a service encounters errors beyond a certain threshold, the circuit breaker opens and temporarily halt the request to that service. This gives the failing service time to recover without overloading it further. It also protects other services from being affected by the failure. Welcome back. Today we will discuss CQRS or the command query responsibility segregation. It is a design pattern that separates read and write operations in a system. Commands are responsible for changing state, while queries are responsible for retrieving data. This separation allows for optimization and scaling of read and write operations. That's the CQRS. Subscribe for more tech. Let's discuss the database per service pattern. In this architecture, instead of sharing a single database, each microservice manages its own data stores. This promotes autonomy, scalability, and agility. Also, each service can choose the database technology best suited for it. Let's discuss the event sourcing design pattern. Imagine your data as a series of events. Event sourcing captures every change as an event. Instead of storing current state, event sourcing records all events, providing a log of how data has gathered over time. This enables audit trail, allow for reconstructing past state, and supports temporal querying for historical analysis. Let's discuss event-driven architecture. In this, systems are built around the concept of events that occurs within the system. Components within the system communicate asynchronously by producing and consuming events. This promotes loose coupling between components as they don't need to know about each other. It also enables scalability, resilience, and the responsiveness. In microservices, each service may have different configuration needs. External configuration is a design pattern where configuration settings are stored outside the codebase at the service. Instead of embedding configuration within a service, they are retrieved from external service like environment variable, configuration servers, or files. This promotes flexibility as configuration can be updated without redeploying the services. It also enhances security by keeping sensitive data separate from the service. So that's the externalized configuration in microservices. Subscribe for more. Let's dive into Outbox design pattern. So in distributed systems, ensuring data consistency across multiple services can be challenging. The Outbox pattern offers a solution. Instead of directly updating external systems, changes are first recorded in Outbox within the application database. This allows for decoupling between application and external systems, ensuring reliable and consistent data propagation. So that's the Outbox design pattern. Stay tuned for more tech insights. In the world of distributed system, network failure or temporary issues can occur. So the retry pattern is like having a second chance. Instead of giving up after a failure, the system automatically retries the operation. This improves the resilience of system by increasing the chance of successful execution, especially in transient error scenarios. In distributed systems, complex transactions across multiple services can be challenging to manage. The Saga patterns provide a solution. It decomposes a long running transaction into a series of smaller, more manageable steps called sagas. Each sagas represent a steps in a transaction and can be executed or compensated in case of failure. We have different types in saga pattern. One is orchestration and another. So let's discuss microservices anti-patterns. Some practices can lead to inefficiencies, complexities, and even failures. These includes monolithic mindset, where microservices are treated like traditional monolithic applications, chatty microservices, over engineering, shared databases, premature optimization, and ignoring non-functional requirements. To avoid these pitfalls, it's crucial to focus on proper service boundaries, maintain a decentralized architecture, and prioritize communication and collaboration among teams. That's how you steer clear of microservice anti patterns. Subscribe for more tech.